Re-exporting names with pub use. When we bring a name into scope with the use keyword, the name available in the new scope is private. To enable the code that calls our code to refer to that name as if it had been defined in that code scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope but also making that item available for others to bring into their scope. Listing 17 is the same as listing 711 with use in the root module changed to pub use. Pub use crate front of house hosting. By using pub use, external code can now call the add to waitlist function using hosting add to waitlist. If we hadn't specified pub use, the eat at restaurant function call could call. If we hadn't specified pub use, the eat at restaurant function could call hosting add to waitlist in its scope, but external code couldn't take advantage of this new path. Re-exporting is useful when the internal structure of your code is different than the way programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house, but customers visiting the restaurant probably won't think about the parts of the restaurant in those terms. With pub use, we can write our code with one structure, but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. Using external packages. In Chapter 2, we programmed a guessing game project that used an external package called rand to get random numbers. To use rand in our project, we added this line to cargo.toml. Under dependencies, rand equals version 0.5.5. Adding rand as a dependency in cargo.toml tells Cargo to download the rand package and any of rand's dependencies from crates.io and make rand available to our project. Then, to bring rand definitions into the scope of our package, we added a use line starting with the name of the package, rand, and listing the items we wanted to bring into scope. Recall that in the section generating a random number in Chapter 2, we brought RNG, the RNG trait, into scope and called the rand thread RNG function. So we said use rand RNG. So RNG is a trait. Then there is an associated function for rand that requires the trait RNG to be in scope. And we are calling it here rand thread RNG genrange 1 to 101. Members of the Rust community have made many packages available at crates.io, and pulling any of them into your package involves these same steps: listing them in your package's cargo.toml file, and using use to bring items into scope. Note that the standard library, std, is also a crate that's external to our package. But because the standard library is shipped with the Rust language, we don't need to change cargo.toml to include std. We do need to refer to it with use to bring items from there into our package's scope. For example, With HashMap, we used this line: use standard collections HashMap. This is an absolute path starting with std, the name of the standard library crate. Using nested paths to clean up large use lists. If we're using multiple items defined in the same package or same module, listing each item on its own line can take up a lot of vertical space in our files. For example, these two use statements, they're talking about this one and that one, we had in listing 2.4 in the guessing game, bring items from standard into scope. Instead, we can use a nested path, or we can use nested paths to bring the same items into scope in one line. We can do this by specifying the common part of the path, followed by 2 colons, and then curly braces around a list of the parts of the paths that differ, like this. So we have this example, and then down here, use standard comparison, comparison, ordering, and IO. In bigger programs, bringing many items into scope from the same package or module using nested paths can reduce the number of separate use statements needed by a lot. We can use a nested path at any level in a path, which is useful when combining 2 use statements that share a subpath. For example, listing 719 shows 2 use statements, one that brings standard IO into scope, and one that brings standard IO write into scope. The common part of these 2 paths is standard IO, and that's the complete first path. To merge these 2 paths into one use statement, we can use self and the nested path, like this. So we have use standard colons IO colons, and then we start the curly braces. In the curly braces we have self, comma, write. This line brings standard IO and standard IO write into scope. The glob operator. If we want to bring all public items defined in a path into scope, we can specify that path followed by an asterisk, the glob operator. Use standard collections, all of them. This use statement brings all public items defined in standard collections into the current scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and where a name used in your program was defined. The glob operator is often used when testing to bring everything under test into the tests module. We'll talk about that in the section How to Write Tests in Chapter 11. The glob operator is also sometimes used as part of the prelude pattern. See the standard library documentation for more information on that pattern.